How you doing, everybody? Randy Richard in the shop. Today we're going to install a Y-axis power feed on my mill. I got the Z one done, and I already had an X one. So hopefully this is very similar without the problems that I had with the Z. I hope this goes well. This is it. It's an ALSGS power feed. Yes, it's made in China. And like I said about the Z1, after doing tons of research on buying these things, they all look the same. They're all probably coming out of the same factory. And various prices from $1,000 to $300. And so I found an outfit that sells these, it sells DROs and stuff. I'll put the link to them. Icron, AIKRON, and they have their own website. You can deal directly with them. And I'll tell you, it was fast. They shipped it in approximately about a week after I placed the order like on a Friday, I think it was, or a Saturday, and so you had the weekend in there and all that, and they had it shipped by the end of the next week. So. And then it took only like 4 days from China, or from Hong Kong, actually. So, it was really quick. Everywhere in the U.S., they're selling Chinese-made ones, and for what I can afford, I have to consider that. What can I afford? And I was able to buy DRO for my big lathe, my small lathe, and these two power feeds for what I would have paid for something from the U.S. or not even made in the U.S. but from a U.S. outfit for one DRO for my big lathe. And these are they're LCD screens. The DROs are actually pretty nice, magnetic scales and all that. So yeah. Anyway, so let's get this thing installed. Hopefully in one day. Not like the 3 days it took me to do the other one.
The instructions cover all the axes, so they're very similar except for you have different hardware and mounting. A lot of parts are very similar. We have slides like that there. They're similar, but the shaft is different. Yes, it's the same as the Z. That's what it is. Great hardware. It actually is very well packaged. Parts.
There we go. And it, looks, as far as this part goes, looks identical to the other one. Your rapid switch, power switch, clutch, and the variable speed circuit breaker. Assembly. This piece here is for a way cover that was on the forward part of the ways, and I just left it there. I lost the way cover in transport when I bought the mill. Somehow the air caught it and blew it off. I need to replace that. So. I think it's jamming on the key here. Other one. It's loose. Pretty tight. And I got the whole puller on here. We'll see. Yeah. That looks the same as the other one. Procedure is basically the same with this one, so I mean it is the same. Oh yeah, those holes line up. These are all shielded bearings, but some of this oil will leak in there. Just because it's apart and I can get to it. So next goes on the feed itself. Then there's going to be a shaft extension and the gear. Now we're going to put a little oil on this bearing. I would rather put oil, but I could put, I guess, grease. I think I put oil on it. I think this goes in here. The instructions do not cover this one exactly. If that's the case, then this needs to slide over that, and that doesn't happen. All right, issue number 1. The screws, the socket head cap screws for here are at least 1/4 of an inch too long. These ones are about 1 inch long, and these are about 1 1/4 inches, and these are bottoming out. Mounting this with the screw holes across here, I can't mount it vertically. It hits the other unit. I'd like to leave this one the way it is, because when you pull on the lever, up is up and down is down. Pretty simple. I'd like to have this one this way, but I can put, if I put it on this way, then this will also work. So that's what I'm going to go to do. So I've turned it, and these holes here are about a 120-degree angle. Well, I don't know, about 60 degrees or so off of there, about. Anyway, I had to drill out. They had two of these holes here and here are not all the way through, so I drilled this one out so I can do that, so I can mount it like so. So I'm going to shorten the other bolts, and then I'm going to mount it like so. Issue number 3. There's a sleeve that goes here. It goes over in that bearing on the drive unit that rides on this. This doesn't fit. So I hope this isn't too hard, and I can cut it with carbide. And I'm gonna have to bore this out. This is just no way fit. There's no burrs. It just no fit. So I haven't measured it yet. So that's issue number 3. So the extension shaft, though, the extension shaft does fit on here. That does fit. All right. Then this is going to go on. So this goes on, and it slides over that. But if it has, it probably has to go farther than that and engage into the drive gear of the drive unit. Well, that doesn't fit over. That doesn't fit either. Doesn't fit over this. So a little measurement of this, and I'm going to have to probably bore it. I'm going to have to bore this out also. So we got a little bit of work to do. So I cut 1/4 inch off of these, and they should be fine in there. There's enough play in the screw holes here to should be able to center up on that for the bearing there to fit right. But that will work. We can make this work. And actually the handle's out here in front, so a little counterintuitive, but it will work. I might be able to take that handle off and re-index it so it's over here, and then it would be in for in and out for out. So we'll have to take a look at that. You know, modify. All right. So I have found, reading this better, I have found that really it doesn't really cover the installation of the y-axis. Not really. So that's an interesting point, huh? It's similar to the x, but it's only similar. It's similar to the z, but only similar. It doesn't really cover it. Because it doesn't show. It doesn't really show the sleeve and extension shaft set up. That's the problem. So, just for information, this measures 629 and 1/10. This is 623 and 9, 624. So we're looking at the, you know, I'm gonna have to figure this out a little bit to see how far. I think that all goes on all the way. Yeah, that does. That will slip on all the way in there. So I'll bore the whole thing out. You know, I was worried that if it's going to ride on the extension shaft part, it could be funky. But I'll confirm here. I should be able to get somewhat of a measurement. If it was up against the bearing in there, bearing to the outside edge is 2.207, and this is just a little shorter, hardly anything. This is 2156, so about 50. This is only about 50,000 shorter. So that goes all the way in there, which is what we want, so it doesn't interfere with the bevel gear. You don't want it to stick out too much and interfere with this. So that's what we'll do. There's always more problems. So this sleeve, right, is skating hard. It's probably easier anyway. I just make a new one, and I'll make it out of pre-hard 4140. Yeah, you know, only about 28 to 32 or so hardness. It's not that hard, but it's tougher, and it will work for this low speed application. Yeah, this will work. That will work. So in situations like this, it's nice to have one of these portable CAD systems that are right here in the shop. And you can pick these up for like $6 or something. They're really cheap.
Make a CAD drawing.
Oh, I don't know if you can see that. Oh, anyway, there's the quick CAD drawing. Did you see that? Yeah, kind of hard. But anyway, it works. Couple taps of that button, 2 taps or so of the button, it's gone forever. Now this is turning. This is going to be the final cut. I'm still not feeding it fast enough. I'm feeding it as fast as I can right now. So instead of taking it out, I'm just going to see if I can slip this in there. Oh yeah. Oh yeah. That's the same as the other one, so that's perfect. I drilled it out to 9/16 and I have to bore the rest. Having a set of pin gauges can be very handy, especially for smaller holes. So I'd say we're right there about 571. All right, I crept up on this a lot, and I sped up to a little over 1,000 RPM and I got rid of the singing a little bit, but I took a lot lighter cuts, of course. And the secret boring well is do spring passes. If you're getting close, just do a spring pass, maybe 2 spring passes, or only add maybe 1,000ths to your dial. Don't add much, if any, and just do spring passes, and you can come out pretty good. This is a 629 minus pin, measuring 629 and 2/10 or so on the shaft, but this fits. I mean, there's just a tiny bit of looseness to it, so I mean, it fits very nice and free. So it should be just fine. Because as soon as I take it out, I'm done with this, right? Pretty much. Okay, so there's a part, chamfered both ends, and I don't know if you could see in there, but really it came out pretty darn awesome on it. Shiny parts are hard to get to focus on, but it came out really nice inside. Let's see if it fits. Oh yeah. Catching on something. All right, I've honed this a little bit. I think it's bent. When the stone goes across, it touches here and here, and I think it's the shaft is for some reason a little bent. Over the years, I don't doubt it. Getting moved around. A 632 pin goes through this, so I'm a couple thousandths actually over of what I'm measuring, and I honed it out a little bit, and I got most of the way, so I'm kind of tempted to just knock it on there. It won't come off probably, but I mean, I'll have a difficulty getting it off if I do. I'm kind of a little bit in a dilemma. Yeah, I'm holding the straight edge on here, and this from about out here, about the last 3/4 of an inch, it has a little bend in it. It's just out here in the end. So I actually filed a little bit, and I'm putting black Sharpie on there, and then putting this on. Give a little bit of turn to see where it's scraping, and then hit it a little bit with a file. You know, all of it is really just up in here because it's bent. It's gapped on that side, so it's bent up like this, and it's making a big difference. Boy. I think I'm going to tap it on. There. So you got past the bend, it went right on. Fits good though. Fits good. Deal with the next problem. So this is the extension shaft, and we know that there's 5 thousandths or something between difference in size between these two, and we know that this fits that. It doesn't fit that. So what I'm thinking, so this end will go in there a ways. This screws on. Hey, that works. Almost tempted about making a new one of those, but I don't know. Anyway, this won't go in, right? So I can measure. I'll measure the difference in length that it has to go, and I'm going to bore that part out. So it can go in there properly. I think that's probably the easiest to do, and then you'll just go over that next shaft and still seat on this one also at the same time, hopefully. That's what I'm going to hope for. Now we do have a little Yahoo in there, but I filed it a bunch, so it's pretty straighter. I might have to file a little more even, but we'll see. All right, chucked up. We'll touch off here. We're going to bore in 7/8 of an inch. It should be enough. 6/26 is tight. It goes. You probably could hammer it in, but it's snug. We only need to take off a total of 3 or 4 thousandths. So this ended up being 629, and that's what that shaft measures, and it goes on and engages. Actually, perfect. There's zero play. It's keyed on to this anyway, so hey, that's awesome. Now we got to do the shim trick. Shim inside here to get the backlash on the gears. You can see it. So I'm gonna make sure this has a little bit of room in here. Otherwise it's going to rub. If you could see the gap there, I don't know if you can see that. It's got a little wobble in it. It's probably been bashed into a few times. Now it's longer, so now it's more accentuated, but nice and smooth. Feels good. Just on a side note, the thing was bent, and the bend was right here in the end, mostly like where the thread was, you know, because probably getting banged, or right here. So I put a dial indicator on it and bent it, slipped a half-inch piece of pipe over, tweaked it around, and I have it to within about 10,000 total run out on there now. So it's probably about as good as I'm going to get. So we're going to call that good. Milled off flat, drilled 90 degrees out from the other hole roughly, just all by eye, and tapped it. This is the handle for the Y-axis, so it's in a different orientation. Just changed it to over here, so it locks on. It has to lock onto a divot, a recess in the shaft. I'm going to make this into a step key that's a ½ inch long, 158 thousandths wide. I'm going to take off about 18 thousandths on each side of the top at 62 thousandths deep. So this is the bushing I made. This is where the key goes, and that keys this gear on. and it has to fit in here. If I had the broach to broach that out bigger, I would, and I'll order one and probably do that in the future. Because the shaft one is not a smaller key like this one. This is 122, and this is, it's probably metric. I didn't measure it. And this one's 158. So we made that step key. Let's see how it fits here. Oh, awesome. First shot. There. That's what we want. That'll be just fine. It's not a high-speed device, but that's going to work. This has to be keyed to the shaft, and the main shaft is better than having it on the extension shaft because this is the driving one. So one thing I did is I played with the position of this and tried different. There's only 3 holes for mounting and one is at the top, but the other holes for mounting this are not symmetrical on there. So I rotated it around and tried different positions, and one hole and gave it so this has a slightly down slope to it, but I wanted clearance for my vice handle here, so I had clearance. With it up where you see it in other parts of the video, it might be up. That was not good because of the vice handle clearance when the vice is over here. So I played with that, and I ended up putting used one hole and put a new hole in so I could have this so it's down a bit, just a slight angle. Did the control knob, so you push the knob in, it goes in, push it, it goes, pull, it goes out. I did a little machine work on that, so it fit back on here in the right position. Alright, I put one thick shim in with a keyway cut in it that they supplied, and it brought it out about 6 or 8 thousandths, and I think it's going to work. I'm going to give this a try. I'm going to put a few shims here also for the dial. Might actually need another shim. We'll see after we get it tight. Now for the key here, it's this really tiny key, and actually it fits in the shaft, but it's too small for this because of that keyway difference. So I'll have to make another step key for this. Put that, it will work for now, but all right, that bound up. I can't move it at all. So, more shims. I had to grind a notch in them for the key. Just use a small air die grinder. Oh, there, nice and free moving. There we go. So I only put 4 of these little thin ones in there. I just put 4 of these little thin ones in. Feels real good. works. So the handle I repositioned down here, as you can see, so that when you push it in, the table goes in. When you pull it out, table comes out. Otherwise, it would have been over here and not oriented. I like that. Now I could probably take a shim out of here also. Oh yeah, that'll work. This is the limit switch for the Y-axis set up down here. There's a rail I mounted below the DRO scale, and I attached the switches, a little piece of angle iron bracket, to the DRO mount for the scale there, and for the reed head. You know, this is the reed head mount. So that's where I put it down here. Now, this, in this orientation, the switch was backwards. So when it hit here, it should have been for the other direction. You can take the switch apart, open it up, and there's two micro switches. All you got to do is flip their position. Take one up and put it on the other side, and then just flip their positions. You don't have to unwire it or anything, so it's very easy to do and very simple. Just pick up, they're on little pins. Just pull them off the pin and flip it over and put it on the other side. Just swap their positions. So it works right. Anyway, this was, so that's where this is down here. If I had put it on the other side, it would have been okay, but I didn't have anything to mount to really. I would have had to build a lot more mount for that switch head. So this was very simple, just a little piece of angle iron, a few holes, and pretty easy. There we go. That's all three of the drives. We have our X-axis. This is an INCO drive, and then these are the ALSGS drives for the Y and for the Z. They work really nice. Now the spring-loaded handle thing, it seems to be okay. It's usually in the way. If the handle's on here, I usually don't even keep the handle on there anyway. So I'm kind of used to taking it off and on, and I don't know if that's going to stay this way. I might just take this off and use it when I need it. That's what I'm used to doing. So I'm pretty conscious about taking it off or on. As far as, you know, if it was engaged on there, I mean, that thing would be whipping around. So, anyway, we'll see about that after I use it for a little bit. All right, thank you guys for sticking with me on that Y-axis. A lot of issues on the Y-axis, but we got it done, and it works great. So, you know, that's how kits are. I think I said this before, and, you know, as long as you're prepared that you may have to do some mods to make a kit work, you know, that's the way it is. You know, you're trying to put apples and oranges together sometimes, but it works awesome now, and I love the drives. The Z-axis one is great. I got rid of my drill. The drill worked good though for many years, so but I think these drives will be a little bit nicer, a little more intuitive to use too, and having variable speed, you know, you can do a little bit more options there. So thank you guys for watching, and like, you know, I said in the other one, DRO stuff for the big lathe and the Lance lathe, and the 11-inch Logan lathe also. So we'll be putting these DRO systems on. Now I also got these DRO systems. I have them install the RPM feature. So I'll install an RPM Hall effect probe. I actually have one on each lathe already, but we'll swap it out for their probe, and hopefully have RPM right here on the screen instead of a separate digital readout. So thank you guys. Thanks for watching and sticking with me. Happy holidays. Please subscribe and click the notification bell so you know when a new video comes out. So we'll get you in the next one.